So we are going to see now the Astable Multivibrator. Astable Multivibrator is also called as a free-running multivibrator. So why it is called as a free-running multivibrator is because it does not require any kind of input. So it is going to be like an oscillator, which do not require an input, but it is capable of generating an output waveform. So normally a stable multivibrator will develop the output waveform based upon the capacitor charging and discharging. So it is going to develop a square waveform. So it is also called as a square wave generator. So now we are going to see a stable multivibrator using 555 timer IC. So this is a basic pin diagram of the 555 timer, and these are all the pin configurations where pin 1 is the ground connection and pin 4 and 8 are tied together for the VCC supply, and pin 2 and 6 will be shorted to a ground capacitor, and pin 7 is a VCC, and between this 6 and 7 we have one resistor which is called as RB, and we have one more resistor RA which is connected through the VCC supply. So this is a stable multi-vibrator connection given using our IC 555 timer and its corresponding waveform. So as I told you, this is going to be the charging and discharging of the capacitor. So now as we see, we have two comparators inside this 555 timer IC, and we have one uh, bypass transistor, and then one SR flip-flop. So where S stands for set and R stands for reset. And these are the two resistors I told you, RA and RB. And this is the capacitor through which we have this charging and discharging. And when you are giving this VCC power supply, this capacitor will begin to charge, and it will charge through the resistors RA and RB. So it will charge to a maximum value of 2 by 3 VCC, and minimum value is going to be 1 by 3 VCC. So now we see a comparators which are connected here. So this comparator will have a high threshold value which is called as VTH and low threshold value VTL. So these threshold values are already set to the levels of 2 by 3 VCC and 1 by 3 VCC respectively. So now what happens is when the capacitor begins to charge through this resistor RA and RB, when it reaches the point of 2 by 3 of VCC, this comparator will be switched on. When this is going to get switched on, this resistor will be, this R value, that is the reset value of this flip-flop is going to be 1. So generally for an SR flip-flop, when reset is 1, the flip-flop will reset, so we will receive the output. So here we can see very clearly. So now this is going to be the connection, and this is the capacitor charging through the resistor R1 and R2. So first we have capacitor charge initially to be 0. And then what happens is, at that time I told you this comparator value is going to go, this first comparator is going to have 2 by 3 VCC, so that will go 1. So the reset value will be there. So when the reset is high, so we will have Q is equal to 0, whereas Q bar will become 1. So that 1 value will pass here to the transistor. So this transistor is actually a ground connector transistor which will bypass the voltage value. So this one of the resistor will be disconnected. So the output, this is what I told you, it is going to be 1, and then it will begin to discharge. So from 2 by 3 VCC, it is going to come back to 1 by 3 VCC. So this is going to happen, and then the next capacitor value will, the next comparator value will go 1. So when this is going 1, it is connected to the set condition of the flip-flop. So when you have set condition, your Q will be equal to 1, but Q bar is equal to 0. So the output is reaching 0 value here. Okay, so similarly, this is going to take place again and again, and you will have the stable multivibrator developing ones and zeros correspondingly. So charging and discharging will develop 0 level, 1 level, 0 level, 1 level. So this is going to get repeated, and this ones and zeros will make the waveform go from high to low, low to high, high to low, low to high. So it will develop a square waveform. So this is what is happening. So the charging and discharging of the capacitor between the levels of 2 by 3 VCC and 1 by 3 VCC will go for 1 and 0, 1 and 0, and that develops a square waveform. So that is why we call Astable multivibrator as a square wave generator. And this is the T on condition. That is, this when it is going 1, we call that as a on condition, and when it is going for 0, we call this as an off condition. So T on and T off will depend upon the resistors. So T on means it is going 1 in. So in this condition, R1 and R2 both will be connected. So we are using this, and the capacitor value C. So in some of the textbooks, it will be mentioned as 0.69. In some places, it will be mentioned as 0.7. Okay, so this is the total time period, putting T on plus T off, which is equal to 0.7 R1 plus 2 into R2 into C. So this is a stable multivibrator whole circuit along with its waveform. Thank you.